Good morning, everybody. My name is Vinod Nair. I'm a career consultant, partner at a consulting company. So today we want to talk about how software-defined storage can truly serve as a powerful bridge between bridging massive data volumes and the need for real-time monitoring, right? So, as you all know, we are living in a data-intensive applications world, right? There is constant need for data. Think of any use case, any industry you think of it. It's AI, data needs, manufacturing data needs, customer data needs, telemetry product needs. There's always an evolution of the amount of data that's needed and the volumes associated with it and how soon you can process it and do some meaningful insights coming out of it. And when you think of these heavy applications that need to access these data volumes, you start with traditional storage options, right? You think of your HDs and your local SANs and all the common storage options. And as the volumes scale, what you quickly will realize is you reach the conclusion that traditional storage options do not help when it comes to real-time monitoring. And that is where software-defined storage really comes into play. So I want to start with a customer example. So I do a lot of work in the manufacturing space. One of the customers, I can't disclose details, but they were creating machinery, and as a part of the manufacturing process, they were creating about 12 gigs of data per second. And this equipment that they're manufacturing is so critical that any delays will have a substantial ripple effect on the supply chain down the road. So early anomaly detection, on-time intervention are like super critical. But now how do you manage data size? You fill up volumes really quickly. So they started by beaming all this to the cloud. Think of the biggest pipes, fattest pipes you can get from the manufacturing facility to the pipe, and the lag was about 35 seconds to the cloud, right? Before they could look at what is happening. In comes local storage, right? Your traditional storage options with this amount of data, we're dealing with a lag of about 8 seconds before you could actually understand what's going on. And when we moved to GDC, which uses SDS with Rakuten inside it, we were able to get that back to under a second. So this is what we call close to real time. While it's not absolute real time, it's close to real time for this volume of data. So I want to talk you through this substantial jump, right? It's almost less than a tenth is what we got it to. The magic behind it is what Rakuten has with their cloud-native platform storage technology. So I'm not sure how many of you are familiar with Google's GDC offering. Anybody who's used it, distributed cloud? Anybody? So Google has it's a relatively new offering. It's called Google Distributed Cloud, and think of it as edge, but that is Google Cloud ready, but on-prem. That's really what Google GDC is. So this particular customer, we were using GDC for them, and GDC by default comes with 6 nodes, and it has all the 6 nodes have the Kubernetes master services in them, and this is where the magic starts to kick in. So the Robin master services are on the 3 control plane nodes. So the way GDC is structured, there's a control plane which is not on the cloud because again, it's on-prem, right? So you have an on-prem way to manage this, which connects to the cloud as needed. And the data services that is used for managing the entire storage pool is across all the 6 nodes. And this is when the magic truly starts to happen, because what it does is, regardless of the type of data you have or the type of storage you have, it creates a continuous data fabric, right, across all your nodes. And it's able to create unique real-time pathways to access these data volumes regardless of how your volume scales. So you could have continuous increase in the types of data you're creating, and it's able to real-time manage how best to access that data. And this is really how how the magic happens. Now, in addition to that, it has you can think of the different workloads that you have today and the different needs they have. So certain types of applications may have real low tolerance for any reliability issues. You may need to have multiple types of data protection layers built in. So there's an immense amount of flexibility that you get when you start using software-defined storage. So here's an example. So let's say you have an application that super critical, right? You can't have any tolerance for fault. you can figure out ways with easy configurations to say, very, very low fault tolerance. I want to have that data replicated not across the same node, I want it replicated across multiple nodes, right? Or you could say, I want it replicated around the same, across the same node, but different disks, right? Or you could say, I don't want any replication, I'm fine, it's all right. Or you could say, hey, listen, I have multiple workloads who want to access the same data volume, and then replicate only that, right? So you have a lot of variations based on the type of workloads you get. And across all these different scenarios, what Robin is able to do is give you the pathways where the workloads do not care about how the data gets used. You could be using any kinds of storage, and you don't need to worry about that. With Robin, it's actually managing that whole thing for you and how best to optimize it for you. So that jump we got from the 8 seconds to 0.85 seconds was in how it is able to navigate the different types of storages and use low latency approaches to get to those data volumes in low latency. So in addition to all this, obviously GDC is an edge-based solution. You have on-prem specific solution options also. And I just want to quickly talk through some of the big benefits of going this route. We talked about the performance, right? We talked about immense performance benefits when you go, you get close to bare metal performance when you start using Rakuten. The other big play here is, as you think of volumes that continue to scale, like the 12 gigs per second, like imagine the amount of volume you have. As you go with traditional options, you end up having to buy a lot of pretty expensive hardware. With software-defined storage, you're really creating that abstraction layer where you can actually just go and get commodity hardware. You don't need the custom SAN arrays and any of that. You could just get commodity hardware and let the software manage it for you. So huge efficiency play. The other big play is, if you are dealing with big storages, you don't need to wait for the step increase in storage volume, right? You could have linear storage increases when you have software-defined storage coming into the mix, which is a huge thing as you are dealing with applications that can go up and down. You don't need to now put a lot of CapEx investment to now go buy your whole rack just because one of the applications is starting to increase their data usage. One other thing that we actually came across, which is very, very useful, is think of solutions or workloads that you want to move from your on-prem to cloud. You're already using some amount of software-defined storage on your on-prem. It just makes it all the more easy for you to move it to the cloud, because at the cloud layer, it doesn't change the way you're accessing your data volume. So as long as your applications are made cloud ready, you can continue to use the same storage volumes because it's already managed through the software abstraction layer. So that makes it a lot more easier in terms of performance. Just a couple other things in terms of what Google has been doing with this cloud solution with SDS with Rakuten is, they have looked at a lot of different options and picked Rakuten just because of how mature their offering is. So I'm not with Rakuten. I'm a consumer of the service, and I think it's incredible how well they have it in terms of maturity. So with this offering, you actually have one throat to choke with Google. You don't need to worry about talking to Rakuten or talking to somebody else or some hardware provider. You get to work with Google, and you get their level 1, level 2 support for any issues you have. So it's pretty seamless, and they have internal ways in which they can manage and coordinate support across Google and Rakuten, which is hard to get. And you get Google data center capabilities in your data center. It's kind of cool. And then the other thing is, because it's embedded into the product, you get a drawdown from your cloud credits. So any SDS-based usage, it draws down from your cloud credits. So it's a double whammy. It's a double win. I don't want to spend too much time on this, but essentially the big use cases that we've seen work really well for using SDS comes in places where there's a lot of data, right? There's a lot of data, there's a lot of growth in data. So think of retail where there's intermittent connectivity and suddenly there's a rush of data coming out. Or manufacturing, like I mentioned, there's a massive amount of volume created with every run. Telecom or air-gapped, so air-gapped is it's an industry term where you do not want data to go outside your walls. So think of high security data, super secure IP that like sovereign states are trying to get after, and you don't want that data to leak. Think like semiconductor industry, for instance. They love an option where you can get capabilities of the cloud and you're able to scale like the cloud, but then you're on-prem, right? Without having a lot of improvement in or CapEx investments needed. So significant advantages of using SDS as you go through this journey with Google. So happy to take any questions that you have along the way. Yeah.
So how is distributed cloud different than Google Cloud in terms of performance or efficiency?
Yeah. So if you think of Google Cloud, it scales, it scales horizontally, right? You're able to scale real time. With Google Cloud, GDC, it comes in multiple configurations. So you have to predetermine the type of scale that you want, and then you could scale within those parameters. So there are, server options, there are rack options, there are single blade options, and it's able to scale. So there are 8 GPU options, for instance, right? For the one that this customer was using. It can scale pretty dramatically in terms of compute across the resources you have. The big challenge that we ran into is the amount of basic storage it comes with. With GDC, they limit it to about 8 TB. So there's an existing challenge that they're working on. But apart from that, pure compute scaling, it scales to, what you're getting into. You're not going to get like the huge burst, but if you configure right for your peak performance volumes, you can actually get the right GDC rack for you.
Do we pay less for GDC?
And it's a managed service, so you end up paying less overall, right? It's a managed service where you don't really need to manage the operations of it. Google manages for you, and you pay it as and it's not a capex, it's an opex. So you pay it as a annual. It's a fixed amount, regardless of how much you use, and you get to use multiple workloads on it too. So that helps.
Fixed amount.
It's a fixed amount, yeah. It's a fixed amount depending on the configuration that you get from Google. So you could have either like I mentioned, like a server configuration or like a rack configuration with multiple sub-configuration types within it.
Does it optimize automatically, or do you have to optimize yourself?
So we had to actually optimize it based on what the customer needs were. Optimizing as you optimize the configuration based on you don't need to optimize the hardware. Like hardware is already it's Google data center quality is what you get with this, and it's using Rakuten inside it. So it's already configured.
But the cost skyrocket when you switch to the cloud center.
Exactly. What's up? Sorry?
Yeah, your cost can really skyrocket if you don't optimize what you need.
That's right. Yeah. You need to also, classic example is in the previous slide, when we were talking about I don't know. So, configuration becomes important even with the storage, because you could have SDS has created Rakuten has created an offering where you don't need cluster-wide policies. So in terms of optimization, let's say you want to have different nodes with different types of configuration. Certain SDS packages out there will require a seamless, it should be consistent across all the different nodes. Rakuten gives you that flexibility, you don't have to. So if you have like replication, like an application is already saying, like Hadoop is saying, I already know I need multiple levels of replication. And Rakuten is saying, you can configure multiple levels of replication. Beyond that, you end up with like so much replication and wastage. You get to avoid that if you don't have cluster-wide replication. So tweaks like that will significantly change how you use the hardware, and it can save you costs.